Hi there, this is David from DTU, the Technical University of Denmark. Welcome back to these sessions. In this session, I want to talk about incidence rate. In epidemiology, we are very interested in determining how quickly a disease is occurring in a population. And with the incidence rate, we can determine how quickly a disease is occurring in populations. This lecture is part of the data management for epidemiological analysis. So what are the learning objectives? After this video, you should be able to estimate execute estimation of incidence rate. And you will be able to recall how to estimate the incidence rate, which is using a very simple formula, and the calculation is also very straightforward. And one important part of all this is that you should be able to interpret the outcome of these calculations, of these estimations. So the plan of this video is that we will first look at some characteristics of the incidence rate, such as the concept, and we will look at how can we estimate this parameter. And we will look at the interpretation of this. So what is incidence rate? An incidence rate tells you how quickly a disease occurs in a population. So a formal definition of incidence rate is the ratio of the number of new cases to the total time the population is at risk of disease. Well, this is how it is, the definition. And we will look at this definition by an example. So let's first look at the formula to calculate the incidence rate. So it's a ratio, and then that ratio and on the letter A belongs to new cases that we are registering. And this notation here, the denominator, corresponds to the sum of the units at risk for all the population at risk in the population. This is the parameter that we need to spend some time to obtain, but it's quite easy. And we will have an example, two examples actually, where you can see how we can calculate the incidence rate ratio. Before we move to the example, let me show you a few important things about the notation of the incidence rate, because it has to do with the interpretation. So the interpretation of the outcome is important in incidence rate, because it's a kind of a jargon, the way we expressed the output of the incidence rate. So the output often is represented as calf weeks if we are talking about calves, and if we are measuring the disease on weeks. It can also be that we are talking about people, and then the notation will be persons, months, can be also persons years, persons even minutes or days. So it's depending on the kind of study that we are measuring the incidence rate. And this is a kind of a combination of the population size by the amount of time of the observation. This will be clearer now because we will look at two examples. So let's say we have a population of 9 kids, and these kids were exposed to heavy traffic, and we wait 5 years. And during these 5 years, we measure the new cases, let's say asthma, that are occurring during this time. And we will take into account children who left the study. We probably lost contact with some of them, and that is important to take into account. Sometimes we will take children if it's that possible. So incidence rate, that is one of the advantages, because we can take into account individuals living and coming into the study. So let's have a look at the output of this study. We have here the nine patients we had, these 9 kids. And let's look at the first case here. We notated with the letter A. And we had that this kid left the study after 3 years. So we count the contribution of these kids during the study, the time at risk he was, and that accounts for 3 years. The second kid was notated as B, and he developed asthma at the first year. So the time at risk he was contributing was 3 years. And you can see that as well the first child who developed asthma in the first year. So the contribution was only 1 year. And these kids enroll not at the start of the study, but after the first year. So the contribution was only 3 years because he left just before the study ended. And we had 2 kids who contribute 5 years each because they started at the beginning of the study and they finish the whole time of the study took place. So what we do in incidence rate is that we sum all the time at risk these kids contribute, which was, if we sum this, is going to be 29. The formula was telling us that we have to it's a ratio of the new cases divided by the total amount of time at risks. Child's at risk. So the number of cases we had in this was only 2 cases, and we have to divide it by 29. So this operation gave us the output of 0.068. So we can say that there were 0.06 new cases per 1 child year at risk. We will see more about the interpretation of this outcome when we do another exercise. We will do another example now. In this example, we will use the larger population, which is quite common in epidemiology. We deal not only with 9 kids, but with larger populations. So let's say that we had 1,000 children, and this was a 5-year cohort study. And this is the outcome of the study in this table. We have 5 years, and we got the number of cases per year of, let's say, asthma, and the time of risk these cases were contributing per year. So you might wonder, why is that 10 cases contribute only to 5 times time at risk? Well, this is because we don't know exactly when these cases occur. Sometimes it occurs at the start of the year or at the very end or in the middle. So as a rule of thumb, we very often assume that the cases occur at the middle, and then we multiply these cases by, in the first year, 0.5, and then it will give us 5 times years at risk. So the same assumption is also for kids presenting asthma at year 2 and the rest. So for the kids having asthma the second year were 15, and so the contribution will be 15 multiplied by 1.5, and it's going to be 22.5 times years at risk. So let me show you the computation of this time at risk. So we have here time multiplied by 0.5 plus 15 multiplied by 1.5 and so on, and we sum up all of this. And the output is 592.5 times at risk for the contribution of the cases. So we still have to sum up the contribution of the kids who were not developing any symptoms of asthma during this study. So we have at the beginning 1,000, and then we rest 175, which were the sum of all the cases we had, and that's going to be multiplied by the 5 years they were exposed. So the total amount of the healthy kids contribution, the time at risk is 4,125. So we sum up these these contributions times at risk for the cases and the healthy population, and it's going to be 4,717. So our incidence rate is going to be 175 divided by the total amount of time at risk, which is going to be 0.0396. What does this mean? So here we have some equivalent expressions of the incidence rate outputs. So we can say, as the output was given us by the sums and multiplications and divisions, was that 0.0396 new cases of pneumonia per 1 person year at risk. So we can multiply this by 10, and then we will have 0.039 and so on, which is still a bit awkward to communicate to some people. So if you want to communicate this to your friend, you might multiply this by 100, and you can say, well, there were 3.9 new cases of pneumonia, of asthma, I was saying, sorry, well, pneumonia, asthma, per 100 persons years at risk, which is a bit better now, isn't it? Or we can also round it and say 40 new cases of pneumonia per 1,000 persons years at risk. That might understand better your grandma if you're trying to explain your experiment or the findings of this example. So at the end, this expresses the speed in which cases were occurring in this study. So, folks, we have learned about the importance of the incidence rate. It's important for assessing the speed in which diseases are occurring in a population. And we saw the steps to obtain this, which is a very simple formula that I'm sure you will remember. You will be able to execute the estimation of the incidence rates after this. And as well, the interpretation, it's about speed, and then it's a bit of understanding how you can now express this to the public or to your colleagues when you can multiply the output by 10, 100, or 1,000, and perhaps rounding, and it will be more easy to understand. So there are some quizzes and exercises, so you will be able to understand much better this concept.